Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to find the area of a region bounded by graphs of three equations. And one is g of x equals 4 divided by 2 minus x. And we have the y equals 4 horizontal line. And we have the x equals 0. X equals 0 means it's the y-axis. So it's the vertical line y-axis. And we're going to use the integration to be able to come up with the area of the region. And at this moment, let me just show you the graph right here, but in the video, you will do it by yourself. Please, your TI-84 ready. Let's see what the region looks like quickly. So you have the purple line here, that's the horizontal line I mentioned, and you have the y-axis over there that bounds the left-hand side of the green region, and then you have the curve. So you have that perfect green region provided to you, and we're going to use, again, integration techniques to be able to come up with the area of the green region. All right, have your TI-84 ready, and let's get started. All right, let's think about this problem. First of all, we have to sketch the region. We have three curves to work with. One of them is g of x equals 4 over 2 minus x. And the second one is y equals 4. That's a horizontal line, right? That's a horizontal line. And x equals 0 is the other name of y-axis, right? Okay, so we have the horizontal line, we have the y-axis, and go ahead and please use your TI-84 to plot 4 over 2 minus x with enough x min x max to cover enough portion of the graph to see what the region is surrounded by. Okay, you can pause the video right now and do the calculation, do the graphing of g of x, okay? So, and I did that for you, and this is what it looks like, okay? So g of x equals 4 over 2 minus x, right here at the top, is the graph that is represented by blue color, okay? So this is in fact this graph here, okay? And then the purple one is this graph, which is just a horizontal line. And we have the y-axis. Let me represent the y-axis by red. Okay, here we go. And the region surrounded by these three curves, or lines, some of them are lines, but lines are curves as well, is the green region. And the question is asking to find the area of this green region. Okay? Again, this is slightly different from what we did in Calc 1 because we are looking at the area between two curves and the functions are given in terms of x so that we cannot really go in the direction of choosing the top curve and the bottom curve based on the y-axis. So for this setup, since everything is given in, like this function is given in terms of x, so that means I'm going to do the integration in x. So for that reason, my top function is going to be this function, and the bottom function is going to be this blue curve, okay? So top minus bottom for the integral integrated from x equals 0 and whatever the x is for this point, okay? So we have to sort of like figure it out. All right, so we'll check that, and essentially the area is represented by, again, the graph of the top, or the function, the top function minus the bottom function, integrated from 0 to this number. Okay, let's just find it out. Find out this number. So this is the intersection of blue and purple. So this is also y equals g of x. So there you go. So we were talking about when y equals 4. So we're solving this for x. Okay, multiply both sides by 2 minus x. And solve this equation for x, okay? So this implies that negative 4x equals negative 4 by subtracting 8 from both sides, so x equals 1. So in fact here, this point is just equal to 1, okay? All right, so I think we figured out most part of this. That the area surrounded by the three graphs is founded by writing down this integral, okay, integral, so the area integral. I'm going to put the limits at the end. The top function is the line, and here we go. That's 4, minus the bottom function, which is 4 over 2 minus x. Okay. This is integrated with respect to x, and the limits would be 0 and 1. I found the intersection point first, by the way. So intersection point, I needed the x-coordinate of this point to be able to find the upper limit in the integration to calculate the area. Okay? The rest is just evaluating this definite integral. Let's do that in one shot, maybe 2 shots, okay? Because we have the integral from 0 to 1, 4 dx minus the integral from 0 to 1, 4 over 2 minus x dx. Okay? And go ahead and do the indefinite integral for this one right here for the second integral. So 4 over 2 minus x is a good u substitution problem for you to work on. Okay, so let me just write that down here. And you call the bottom to be u, so that du equals negative dx. All right, and then this integral turns out to be 4 du with minus 1 here over u. Okay, if you integrate that, it's an ln type integral, so minus 4 ln absolute value of u plus c. Okay. So I'm going to go ahead and use that. All right, so this is 4x. Lower limit is 0, upper limit 1, minus. There's another minus coming from the integration here that I did right here. Okay. So it's plus 4 ln 2 minus x, because that's ln absolute value of u, right? From 0 to 1. If you want, I can consider all these evaluations. I can do all the evaluations in one shot, right? So I'm going to plug in the lower limits, and in fact, I'm done with this calculation, so I can get rid of that all the way. There we go. Let's plug in 1. 4 plus 4 ln 2 minus 1. Minus, I'm going to plug in 0. 4 times 0 is 0, plus 4 ln 2. Okay. This is ln 1, right? Ln of absolute value of 2 minus 1 is ln 1, which is 0. Okay. So now I'm down to 4 minus 4 ln 2. And if you want, you can get an approximate value with your calculator, but this is the exact value. So if you punch in this to your calculator, you get 1.227, which is in fact the value of this integral. Okay, this integral. So that's the area enclosed by 3 graphs. Area of the region enclosed by 3 graphs, 4 over 2 minus x, y equals 4, and the y-axis. Okay. Again, in this question, you were supposed to find the intersection point, and we did that by sort of like equating the y's of both equations. So we were solving 4 over 2 minus x equals 4 for x, and that's how we found this x equals 1 here. All right. I think it's the end of it, and thanks for watching. I'll see you in another video. Bye.